Hello folks, we take the exercise 5.2 now and this is our part 1. The initial first two problems, we have to find out something called as a modulus and the argument. So modulus, we have part of it, we saw it in the multiplicative inverse like x squared plus y squared. R, which is the modulus, is given by root of x squared plus y squared. So let's directly do this. They have given us, we have to find the modulus and the argument. So z is minus 1 minus I root 3. Let's identify what is x here. X is minus 1 and y is minus root 3. How did we get this? The real part we call it as minus 1, the imaginary part we call it as 1. Having got this, R becomes easy. Modulus, what they have asked is therefore, let's right away find out the modulus. Modulus R is root of x squared plus y squared, that's all, positive root. So it will come to minus 1 squared plus minus root 3 squared. How much does that come to? This is 1 and this is 3. 3 plus 1, 4. Root of 4, 2. So it will be root of 4, which is 2. So we are done. Modulus we have got. Next, they have asked us to find out the argument. So, modulus. I don't know why I'm writing capital here, but it always comes as capital. Okay. Then they have asked us to find out modulus and argument. So now for finding the argument, there are two facts that you should take into consideration. We know that. What is that? What is that we know? We know that cos theta is x by r and sin theta is y by r. That's a fine formula. We will use this. So what is our cos theta now? X we know it's minus 1 by 2. And sin theta, it is going to be minus root 3 by 2. Now, things to note over here is both sin theta and cos theta are negative. So, where could be our angle? Because both are negative, it has to be in the third quadrant. Okay, that's a place where both are negative. So, actually, what is our argument? Our argument is in the third quadrant, which means it is pi plus theta. It's of that form. Moment you get theta, your work is done. You found out the argument. Now, how do you find out the theta? By looking at these angles, you will get to know the theta. At what cos does the angle become half? At what sine does an angle become root 3 by 2? At 60, isn't it? Cos 60 is half. We forget the sine. For the sine, we have done the settlement. Now, we only look at the magnitude. So, it can be 60, cos 60 it's half, and cos 60 it is root 3 by 2. So that theta of yours is 60. So it is going to be pi plus pi by 3. Now there's a problem here. Okay, we equalize. Let's see what this angle. It is coming to 3 pi plus pi, 4 pi by 3. The problem is arguments are generally written between minus pi and pi. We don't allow it to go beyond minus pi and pi. Now this is 4 pi by 3 means it is in the third quadrant, it's more than pi. So we don't allow that. In order to get it back, but there's no problem. In order to get it back into our range, what we write it, how we convert it is, we write it as minus 2 pi minus that given angle, whatever you have got. It will help you to get it into your required range. So what will come here? This is into 3 into 3. 6 pi minus 4 pi by 3 comes to minus 2 pi by 3. And that is your, that will fall into the range which you require. So if in case you have it falling out, just use this minus of 2 pi minus whatever angle you got and you will be able to get through it. So that's how it goes. Now we come to the second problem. There also you have to find out the modulus and the argument. So let's see how this comes. Here again, let's identify the r. Sorry, let's identify the x. It's minus root 3. The y, it is 1. So like that, the modulus is root of minus root 3 squared plus 1 squared. So that's 3 and 1, 4, again root 2. Sorry, 4, so 2. Right, 3 plus 1 is 4 and you're getting 2. So that we have got the modulus as 2. Now, we know that it has got become identical, no? Both it is, yeah. We know that cos theta is x by r and sin theta is y by r. So what is our cos theta? It is minus root 3 by 2. And what is our sin theta? It is 1 by 2. Because cos is negative and sin is positive, which is a quadrant, second quadrant. So that way we can predict our argument. Our argument is in the second quadrant, which means it is pi minus theta. Now theta you will get with the by looking at the magnitude of these values. And which is that cos which gives you root 3 by 2, and which is that sine which gives you half, 30 degree, right? So this is 30 degree, which is pi by 6. So how do we equalize this? 6 pi minus pi, which is 5 pi by 6. So that is your argument. Here the argument will come as, the argument will come as 5 pi by 6. The modulus will come as 2, and the argument will come as 5 pi by 6. That's about our problem number 2. Now in the problem number 3, we shift from the normal working, and this they ask you to express it in polar form. Polar form is just one step ahead. We have to get the modulus, we have to get the argument, then we have the polar form expression. So let's move. Here, what is our x? It's 1. What is our y? It's minus 1. So what is our modulus or r? Modulus r is root of 1 squared, 1 squared. So 1 plus 1, which is root 2. So we know that. Cos theta is x by r, and sin theta is y by r. So that way cos theta is 1 by root 2, and sin theta is minus 1 by root 2. So we have to find out that quadrant where this theta has the cos positive and sin negative. That happens in the fourth quadrant. So your argument is going to be 2 pi minus theta, and that will work to 2 pi minus theta. Now we look at the magnitude, which is that magnitude, or which is that angle where you get cos as 1 by root 2 and sin as 1 by root 2. It's pi by 4. So therefore it is 2 pi minus pi by 4. How much does it come to? It comes to 8 pi minus pi, 7 pi by 4. We can't take this argument because it is coming in the fourth quadrant. We have to have our values only between minus pi and pi. So in order to get that shift, we will make it as minus 2 pi minus 7 pi by 4. And see how much does it come to when we equalize. 8 pi minus pi. So that is minus pi by 4. That's it. Minus pi by 4. Now the polar form. Its polar form. That is 1 minus I in polar form is you have r into cos of the argument plus I times sine of the argument. So cos of minus pi by 4 plus I times sine of minus pi by 4. So this is the polar form of problem number 3. With this we finish this video. Remaining problems in the next one.